Okay, guys. Um, so what I'd like to do is we've been doing lots of stuff at the same time. We've been and the reason I'm doing that is so you see connections between different kinds of equations and the graph, and so you kind of had a panoramic picture of quadratics, and that's what all those problems were. And we looked at different methods going through that, and so I've thrown a lot out at you. And there's really nothing else to give you, but we're going to zero in on just some of those key things now. In particular, we're going to look at three different methods that we've done already. The most recent one is the quadratic formula. The oldest one was factoring. If you go back to the first few problems, we were factoring stuff and completing the square. And the factoring method we used for two things. We used it to get into factoring form, but then we also use it to help us find the x-intercepts. Okay, and when you find x-intercepts, you plug in 0 for y and you solve. And if you notice here, y is 0, and we're solving for x. So in a sense, all this is we're working on finding x-intercepts here, okay, or roots, or zeros, or x sometimes we call solutions. Completing the square we've used already for putting it into vertex form. But then also, once it's in vertex form, we found x-intercepts where we set y equal to 0 and solve. And so that is another method. And so we're going to compare these methods, and I organized it here so that, like number 37, we're doing the same problem, but three different ways. I'm not so focused on the answer, but the method, that you understand the method to get there. Okay. I'm going to work on 39 with you first, just because 39 is more generic type problem. 37, 38 are more special cases. Just to go through those methods. So on 39, we have the quadratic formula, which uses the coefficients of our equations. So A is what? 1, B is, and C is 8. And did you guys remember that or memorize that quadratic formula yet? Okay. So you want to memorize it, okay? You haven't memorized it yet. And then plug those pieces in. Like so. And then then you simplify it. And I always just do the multiplications first. I do -6 or -1 times 6, 6 squared, -4 times 1 times 8, 2 times 1. Oops, not 21. And you know, on last night's homework, if you found like you were making errors in this process, just be careful, be organized with your work. You know, hopefully you saw where your errors were, but you need to do the subtraction part here. So we get -6 plus or minus square root of 4 over 2, and we know the square root of 4 is 2. And can I divide by 2 here? You can. But when you divide, you got to be careful here. Here's a common mistake. I've seen people do this. What's wrong with that? I have two numbers in the top, right? I have the -6 and the plus or minus 2, and I need to divide them both by 2 if I'm going to divide. Okay, yeah. Okay, so you're saying back up, so maybe at this stage here. So again, because both parts are underneath the 2, if I'm going to treat it like one fraction, I'm going to have to divide them both at the same time. But what you can do if you wanted to, you could split it up to 2 fractions. You can say negative 6 over 2 plus or minus square root of 4 over 2. And so you could see when you split it up that both of them have to be divided by 2. And so you go ahead and make that negative 3, but make sure the square root of 4 stays underneath the 2. Okay? Where people make mistakes is if they don't divide that square root of 4 by 2. Okay, so still we're after solving for x here. And I have x is equal to negative 3 plus or minus 1. And if we don't have any square roots, we need to split that up. So we get x is negative 3 plus 1, and we get x is equal to negative 3 minus 1. And so 2 values for x, negative 2 and negative 4. And here the instructions are just to solve for x. I'm not saying find the x-intercepts, so we don't have to put them as points. Just get x values. Now if I said solve for the x-intercepts, then you'd do one more step. You'd say negative 2, 0, and negative 4, 0, and be done, right? But these are just solutions. Okay, so that's quadratic. Then we're going to try the same problem using the factoring method. If you do the quadratic method, quadratic formula, and your answer has a square root that you can't get rid of, so say we had square root of 5, then we've talked about this before. We said, well, then it's not going to factor. Remember that? It's only going to factor if your x values give you fractions or integers if they're rational numbers. And so if you, for some reason, if you end up with the square root of 5, an irrational number or maybe an imaginary number, then you're going to skip step 2 because it's not going to factor anyways. So you could try factoring it, but you should find that it won't factor in that case, and you go to step 3. Okay. So the middle one, the factoring method, only works on factors. The quadratic works on everything. The completeness square works on everything. Factoring's a little picky. Okay. Will this one factor? Yes, it will. And don't cheat, but we know what it factors to already, right? X plus 2 times x plus 4, because we have that. But let's pretend, let's start from scratch again. Okay, and I want you to pretend you don't have that knowledge. But you've already made these connections, which is good. Okay. So what we've said when we factor, there's different kinds of factoring. There's the difference of 2 squares. There's the GCF factoring, where we just divide something out of everything. There's a trinomial factoring, which is the most common. And those are the 3 kinds that will come up for us. There is also a difference of cubes and sum of cubes. I don't know if you remember that. That was way back there. We're not going to bring that up here, though, because we're working with quadratics, not cubics. Okay. So what we said, though, is we're looking for 2 numbers whose product is 1 times 8. Or they say A times C, because now you know what A and C are. And whose sum is B, which is 6. 2 and 4. And so then we break this from 3 terms to 4 terms. So x squared plus 2x plus 4x plus 8 equals 0. And then we factor by grouping. The first half we can factor an x out. The second half we can factor a 4 out. And if we're doing this right, don't forget to equal 0 each time. You should have x plus 2 in parentheses, and we do. So we factor the x plus 2 out. And get this. And I don't know if you remember me saying there, sometimes you can take that shortcut. You guys remember when you can take that shortcut? If A is 1. If A is 1, whatever you get here, the 2 and the 4, will always match what you get when you factor. If A is 1. If A is not 1, then you have to go through this process. So just FYI, okay? So then once we have our factors, we set each factor equal to 0. And solve. We get x is -2 and x is -4. And it's a good idea to check, is that what I got from the quadratic formula? Yes. And so we're on the right track. So that's method number 2. Method number 3 is completing the square. And completing the square was the method where I said, well, first we need to make sure A equals 1. So we need A to equal 1. And then we're going to find, remember, b over 2 squared. And then after we do that and work through something, remember it's always going to factor to x plus b over 2 squared when we go through that factoring part. Okay, so we're going to use that to help us solve. Now you guys are used to using completing the square to get it into vertex form first, and then you solve. But our goal is just to solve here, so I'm going to work at it a little bit differently, and here's how. Because it's an equation equal to 0, I'm going to move the 8 over first, because we can. Right? That's not, we don't need that for completing the square. So x squared plus 6x is equal to -8. That's my first step. Make sure A is 1. Is it 1? Okay. We have to have A being 1 before we find the B over 2 squared. And then we're going to find B over 2 squared. So B over 2 squared is what? Which is 9, right? So I need a 9 here to make a perfect square. But because I added a 9 there and the 9 wasn't there, I need to keep my equation balanced. So I have two options. I could add 9 and subtract 9 on the same side of the equation, or I can add 9 on one side and add 9 on the right side. Both keep it balanced. Because I don't need it over here, I'm just going to add 9 over here as well. So this is a little different than what we're doing, but it's the same thing. Normally we'd keep the 9 minus 9 on one side. So then we factor. And you can go through this kind of factoring, and it'll factor. But it's often quicker, and not always will we have integers. Sometimes we'll have fractions here. And so it's really nice to remember it's just going to factor to this, x plus b over 2 squared. And so that's going to be x plus 3 squared is equal to 1. So we've solved stuff like this before. So what happens next? You know what the next step is? Take the square root of both sides. And we end up with x plus 3 is equal to, good, don't forget the plus or minus. That's how we get two answers, with the plus or minus there, okay? And then we subtract 3. And you get two options, -3 plus 1 and -3 minus 1. And the first one is -2, the next one's -4. And, oops, forgot my negative. And it doesn't match the other cases. Okay, so now I've done the same problem in 3 different methods.